Hello. In the previous video, I introduced the basic structure of a confidence interval. And here, back to the example of pregnancy due date, like expecting date. And think about two estimators. Suppose that I met two doctors who gave me a different form of estimator. The first doctor told me that the baby will be born sometime between February 5 and February 25. And the second doctor told me that the baby will be born sometime between January 1st and March 31st. Which is more informative? Which is more informative? Or put it this way, which is more helpful to make decisions based on. It's not a statistics question, just this is one more question, brain teaser. And I think estimator 1 is more informative because estimator 2 does not need any professional knowledge. Even I could estimate, I could think about, so this is like anyone can say. So if I see a woman with like big belly, then even I can say, oh, you have a baby, you may have a baby soon, something like that. It's no difference. So to get like estimator 2 basically delivers no additional information. It's not a medical information at all. So so as I said, estimator 2, I believe estimator 2 contains little information. Anyone can say that without checking anything. Just by looking at the belly, I can say that. But now, then put it this way. The confidence level is the probability of correct estimator. The probability that your estimator contains the true parameter. Which estimator has the higher confidence level or higher probability of containing the true parameter? True date of birth. Guess. The answer is number 2 again. Estimator 2 is more likely to be true because, for example, my son was born on February 3rd. So the first estimator is wrong. It was wrong, but still estimator 2 is correct. So as you see, if the baby is born between January and February 5, 1 is wrong, but 2 is correct. And after February 25, 1 is wrong, but 2 is correct. So in that sense, the probability of containing the true birth date is higher for estimator 2. So then let's compare these two. What happened? What just happened? Why do I ask you these questions? Estimator 1 had the margin of error of 10 days. The due date was February 15th, but it allowed plus minus 10 days around the due date. But it can be wrong. It may be wrong. My son was born on February 3rd. However, now think about this. When I say, oh, baby will be born between January and March, the margin of error is 45 days. 45 days, which is near infinity. It's just anytime. So the confidence level is nearly 100%. It's very difficult to be wrong, right? So this is good. In this sense, it's good. Itself is good. The confidence level itself is good because it's very high. However, it contains no information. You don't need any knowledge. You don't need any additional data, any examinations to say this. So it contains no information, but still it is almost always correct, right? So for example, like if I see a pregnant woman, I may say, oh, your baby will be born within a year from now. It's almost always correct, but it's nothing. It's not an estimation. It's useless estimation. So that is a trade-off. Trade-off between confidence level and margin of error. There are two desirable properties for an interval estimator. One is that we want to have the smaller margin of error, because as you can reduce the margin of error, that means the error itself is unlikely to happen. You can make the margin of error smaller because error will be small, which means your estimator is more accurate and more informative. You can narrow down the final candidates, like. But on the other hand, you also want a higher confidence level. Literally, it's about the probability of correct estimation. So, who wants lower confidence level? You want, whenever you estimate something, you want to get it correct. So, and higher confidence level means more probability of correct estimation. But as I said, there's a trade-off between them. To have a higher confidence level, a simplest way to obtain a higher confidence level is to increase the margin of error. If you allow super large margin of error, then any kind of error will fall into the interval. So you're always correct, but it means nothing. Like, let me think about this. I don't know who you are. I have never seen you, maybe, but I can estimate your height. I guess you are between 1 to 10 feet tall. Your height must be between 1 foot and 10 feet. Am I correct? Must be correct. It can't be wrong, because the margin of error is too large. So the estimation is useless. There is no point of doing this estimation. That's the trade-off. Even if it is always correct, has no information. So then we have to balance them. We have to balance out how much we sacrifice in one dimension and how much we sacrifice in the other dimension. So in practice, the way we balance them out is to fix the confidence level first. So confidence level is how the probability of correct estimation, and you set the target first. Like, say, I won't be correct with 99%. I won't be correct, like, say, 90%. So you fix the acceptable confidence level first, and then based on the confidence level, you choose the margin of error which minimizes the margin of error within the confidence level, at that confidence level. That's how we balance these two guys trade-off. So the usual choice of confidence level is 10%, I like say 90%, 95%, or 99%. These three probabilities are the most commonly used confidence levels depending on the context. So for example, when you choose 95% confidence level, it means you admit that you can accept 5% error probability. You know that there may be error with 5%, still you want to make it more compact. And if you choose 95% confidence level, then the resulting confidence interval is called the 95% confidence interval. And 95% is kind of standard. So it is correct 19 times out of 20, or wrong once in 20 times. And then think about this. Which of these three yields the widest confidence interval? When the confidence interval will be the widest? I am going to continue this video, the lecture in the next video. So think about this question. See you in the next video.